And the custom systems and semi-custom systems that we do are leveraging all of this existing technology, but the result that Sealevel seeks is to build the final product.
In this episode of Embedded Insiders, contributing editor Rich Nass chats with Earle Foster, Senior Vice President of Sales at Sealevel Systems, about how to build embedded systems without starting from scratch. They explore when to rely on fully custom and off-the-shelf components and where semi-custom solutions fit in. Later, Ken talks with Soracom CTO and co-founder Kenta Yasukawa about the company's latest GenAI developments with a quick plug for our upcoming AI at the Edge Day. But first, Ken and I break down the latest news on NVIDIA's H20 chip and developing exports around advanced AI chips. Hello and welcome to the Embedded Insiders podcast. I'm Assistant Managing Editor Tiara Oliver, and as always, I'm joined with our Editor-in-Chief, Ken Briota. So this week was looking at some somewhat recent news that I've been seeing circulating within the past couple days, and I just wanted to, get your opinion on it and let the audience, share their opinions as well.
Yeah, and always eager to hear what you folks think about the stuff we talk about here, of course. So feel free to drop us comments on LinkedIn or wherever else. But there's some interesting news that you've been following. Why don't you give us the rundown?
Yes. So today we're talking about NVIDIA's H20 chip. It's supposedly a modified and lower performance version of one of their more advanced AI chips. And they've basically created it to comply with regulations on what kind of technology can be distributed globally and overseas. So I kind of thought it opened up a bigger discussion because supposedly companies other than NVIDIA, like AMD and Intel, are also willing to redesign and downgrade their chips just to maintain these global relationships and customers. And I thought it opened up a bigger question about what it means or what this says about the future of chip design. Are we moving forward where major companies are, regularly producing custom and specific chips, not only for like technical needs, but even just for market means?
I mean, I don't know if that's a change. That's sort of been one of the driving factors in chip design, I think, for the whole time. Designing a chip that the market doesn't need or want doesn't make very much money for the company. But generally speaking, those two often went together. The faster, the better, the more efficient, the more powerful the chip, the more the market wants it as a rule. Although I think there is a decent argument that the power and speed of some of these chips is outpacing the market's needs at this point. But that aside, I think that this is sort of an artificially imposed thing. The idea of going backwards for a market being imposed by a political function more than a market function is interesting. I also would be surprised, or would rather be unsurprised, if I discovered that some of the major chip manufacturers and sellers are going to circumvent this and start selling powerful chips, maybe different lines of chips or whatever, to whatever market. The Chinese market is the biggest semiconductor market in the world, at least in terms of consumption. And if they can start increasing the revenue to make it more directly competitive with markets like the US or the EU in terms of revenue, why I can't imagine them not doing that, right? It seems like the political force. I would be surprised if it was enough to keep the market force from driving those decisions. Does that make sense?
So, yeah, I mean, I feel like for those who maybe aren't as deeply involved in our industry, we're all assuming we're just moving forward, we're advancing as quickly and as powerfully as we can. But it's like sometimes I think this brings an interesting perspective of like sometimes we just have to meet the market where it's at or customers where they're at. I don't know. I feel like this is something that's obviously still developing. News stories are still being posted.
Yeah.
So I think it's something cool we can keep our eye on to see where it goes.
There's an interesting analog here, on the, in terms of a limiting factor that's not directly related to the market, but an outside force,
Mhm.
the idea of sustainability and energy efficiency, that could easily have had an impact on speed, power, etc. Because the more you increase those things,
Mhm.
the more power you need, the less sustainable, arguably, the less ecologically friendly the any given chip is. Um, and so you'd think that the sort of environmental pressures and the pressures to be more energy efficient, not just for cost, but for sustainability purposes, would have potentially slowed growth, but it hasn't. It has pushed innovation in the sustainability side to some extent. Some would argue, myself included, not enough. But there that which could have slowed speed and power growth doesn't seem to have. So I'm not sure that there's going to be a big slowing based on political pressure
Mhm.
or non-market factors. That I think the only thing that could slow that speed and power growth is a market that wasn't buying it, that didn't want it. And the for what I can tell, the best litmus test for that will be Blackwell. If NVIDIA Blackwell sells well, and as it's hitting the market, mass market now, um, and the market broadly seems to want it, then we haven't hit the ceiling of what the market wants yet, because that is the sort of big elephant in the room, so to speak.
Right. And I think we're seeing what a little bit of what NVIDIA's up to. So I think in the next couple of weeks, hopefully we can hear more about AMD and Intel and everyone else's who's supposedly, you know, hopping on the trend or whatever you want to call
Yeah,
it.
yeah.
Sustainability is an interesting perspective as well. I didn't even think about that.
Yeah, it'll be interesting to see if some of the companies that are less tied to US regulations
Mhm.
start doing more business with China and then start doing more manufacturing and more silicon sort of edging into that marketplace to get a piece of that Chinese market, where the US is having a regulatory, let's say, instability.
Now, here's Rich and Earle Foster, Senior Vice President of Sales at Sealevel Systems.
And here we are with Earle Foster. How you doing, Earle?
I'm doing great, Rich.
Good. I'm glad to hear that. I couldn't think of anybody better to answer this question about, do I design my own system from scratch, or do I work with a provider who has, I'll say, pre-built solutions? And that may not be accurate, but I'm going to go with that for now, and you can explain to me why I'm wrong. But I'm a guy who likes to start from scratch. That way I know what I'm getting. I pick my processor, and I get to choose what I want. I pick my own operating system. I get to lay out everything. I know it's laid out just the way I want. Um, and you're probably going to tell me that I'm wasting my time. So before I say further what you're going to say, let you say it yourself. Should I be designing myself or not?
Well, you certainly can, and there's some instances where that may be the best solution. However, oftentimes you can get a better outcome with what we call semi-custom, which combines the advantage of full custom with some of the advantages of commercial off-the-shelf. So with semi-custom, you're using proven building blocks that will help to eliminate risk in the project so that you're not reinventing the wheel, so to speak. And also it shortens, in most cases, it's going to shorten the design time and allow you to get your product to market faster.
Okay, so you threw out a very vague term, building blocks. What are building blocks?
Well, several different things. So Sealevel, for instance, to use our company as an example, how we do semi-custom is we use our library of intellectual property, mainly electrical circuits, but also mechanical designs. A library that we built over the last 40 years of electronic design and building ruggedized industrial computer systems. So we have done work across all sorts of different I/O, different processor technologies, the software frameworks to support all of that. And so we're able to pull from that existing pool of technology and apply it appropriately to optimize the solution for whatever the current task is.
So go down one more level. Are we talking about complete analog circuitry? Are we talking about cooling systems? Are we talking about a processor and a chipset, all of the above, or something completely different?
It can be all of the above. And so mainly we find that Sealevel is doing the electrical design for sure, but oftentimes the customer will want a complete solution. So we can provide either the electrical printed circuit boards and the customer add their own unique, maybe they're putting it in a unique enclosure or a part of another system, and they'd rather have just the electronic assembly. But in most cases, we're providing a full industrial computer that's designed to meet whatever the thermal characteristics that are required are. And the customer can get that turnkey, and we can add all of the compliance as well to go along with that, should there be mil specs or UL, whatever the particular compliance is that is needed for that application.
What about rugged? Where does that fit into this equation of should I do it myself or should I work with somebody like Sealevel?
Well, there's a special skill set we like to think with building ruggedized systems, things that we've learned over many years of doing this and working in that environment. It often involves, you think most commonly about thermal and vibration tolerance when you think about rugged, but really you have to design the electronics to be compatible with that. So it's really, a comprehensive design to be able to get the end results that you need for an extreme rugged system, something that's going to live in, whether it's a defense environment or maybe on a truck in a transportation environment. Maybe it's oil and gas and it's out, in remote locations. These applications also share the need for high reliability. These systems need to, if they fail, it's usually very difficult to either get to the system, or the outcome of the failure is, in some cases, catastrophic. So, you've really got to have the comprehensive design that is going to supply that ultimate reliability for that tough environment.
Now, would I be using Sealevel Systems to build my prototype, and then I would take it to a contract manufacturer to build me my 10,000, or would I be looking to you guys to do that, or do I have the option of either way?
Well, that's a good question. There are some companies out there that will do design for hire work. That's not Sealevel's business model. We're at our heart a manufacturer. So we, if you go to our website, you'll see that we have over 300 standard products of industrial computing and I/O. The custom systems and semi-custom systems that we do are leveraging all of this existing technology, but the result that Sealevel seeks is to build the final product. We do that here in our 52,000 square foot facility in Liberty, South Carolina. By the way, we're AS 9100D rated. So that's, of course, a very challenging quality standard to achieve. And so you get the comfort of made in America. You get support that goes along with that. We have our engineers sitting right literally, within quick walking distance of the manufacturing floor. And so all of those things are brought to bear on providing the solutions that are needed in these critical applications.
Now, you mentioned semi-custom and custom, but we didn't really talk about, well, what if you guys already make what I want, or you make something very close to what I want, and I'm good enough with that, so I don't have to pay for any NRE. Is that the option often?
Well, yes, sometimes the projects, as I mentioned, we've done hundreds and hundreds of semi-custom projects that we can pull from. And sometimes they're very close, depending upon the business case and the volume involved. There may not be an NRE involved. Other times, we try to keep the non-recurring engineering to a minimum. It's really not where our, that's not our profit center. We're looking, again, to manufacture the final product. And so we really try to keep that, burden of the design costs to a minimum, so that we can deliver the best solution in production to the customer.
Okay. What if I'm adamant about using something that's not really in your portfolio, like a processor that I think works better than anything that's on your line card? What would you tell me?
Well, we are open to learn new things. We're always learning new things. And so that those projects, oftentimes you're just adding one piece of technology to an existing portfolio of semi-custom. So for instance, I can think of a project a few years ago we did that required some custom audio processing. And the customer was familiar in this area with a digital signal processor that was really well suited to the job. They happened to have engineering capabilities to even provide the software, the firmware for that digital signal processor. So in that case, we actually combined the customer's know-how, being the selection of the digital signal processor. We designed that into the hardware with all the other I/O and computing requirements that were required, delivered it to the customer so that they could then add the firmware for the DSP. And so each particular application it always seems to have its own unique challenges and personality, if you will. And so we're very flexible. We spend a lot of time up front with the customer defining the statement of work. So we really want to agree 100% on what the deliverables are. And so early in the process, we involve our engineering team. We'll often meet on site, or at least we meet with the appropriate folks from our customer to thoroughly define what the requirements are prior to getting started. And that's really one of the secrets to this, is to make sure that you've got that formula for what you want to deliver figured out before you begin.
Okay. You talked about your engineering guys are always in learning mode. Are you learning about artificial intelligence, and are you hearing from customers that it's a must-have at this point, or are your customers still poking around?
No, actually, it's we have several active projects right now around AI and machine learning, and we're very excited about that. We have been learning about that area of technology for a number of years now, and are bringing it to bear on real, industry solutions. Some of those are using, what you see a lot of press about, the NVIDIA platforms, the Orin AGX in the case of the ruggedized systems. Also, for applications that don't require the extreme rugged, we're using the NX solution. But also with traditional x86 applications, you can add the GPU building block so that you're really combining the capability of the GPU for a specific use case with the traditional programming method that everyone's familiar with in the Intel environment.
Okay. One more for you. We talked about when semi-custom is the right and when off the shelf is right. When do you tell me to go back and just build it myself?
Well, if you have the capability and that's really your business, you may want to. However, we find that more and more so, customers are really focusing on where their subject matter expertise is. Oftentimes, that's in a particular market and may involve, a lot of times it involves software. So, they can, a system that's very similar to one that we provide in defense might be the answer for an energy application, for instance. And really the difference, other than some minor hardware modifications, is really the programming of the system that the customer adds to meet their unique requirements.
Do you run into the situation where the potential customer engineering team says, we could do this, and you're saying to yourself, no, you really can't, but okay, go ahead, try it, and then we'll see you down the line. Is that a common occurrence? The not invented here philosophy?
Well, I can say I have run into that, and sometimes, again, if a customer is set up to do that and they have, the integration with to support the electrical design, the firmware, and maybe OS support to go along with that, and the thermal requirements, they may be successful. But more and more customers don't have that broad level of expertise, and they'd rather outsource that to a company like Sealevel and focus on what they want to do and what they're good at.
I was out of questions, but you just reminded me of something else that I forgot to ask. Do you care what operating system I want to use as a customer?
Well, we're familiar with most of the commonly used operating systems. Of course, you see Windows 10 and 11 applied broadly still, but many different flavors of Linux. So we have a technical staff, both in engineering and in tech support, that make sure that we're going to provide a platform that supports whatever that user's environment is. In some cases, we had a recent project just a year or so ago that used the QNX operating system, and that was a bit of a learning curve for us that we successfully implemented, and it's working out great. So we're not afraid to learn new things, but for the most part, for the commonly used x86 environments, for the Windows and different flavors of Linux, we're able to support that out of the box.
Well, thank you, Earle. You very succinctly put things into the boxes that make sense for me. When I should be doing it myself, when I should be buying standard off the shelf, when I should be doing semi-custom, and when I should be doing full custom. Each one seems to have its own unique requirements, and I think I understand it now.
Well, super. Glad to talk to you about it.
Thanks, Earle.
Now, here's Ken and Soracom co-founder and CTO, Kenta Yasukawa.
Hello, friends, engineers, and developers. Welcome to another segment here in Embedded Insiders. I'm Ken Briota, Editor-in-Chief of Embedded Computing Design, and I'm very happy to have today as my guest the CTO and co-founder of Soracom, Kenta Yasukawa, and we're going to talk about some very exciting new news. Kenta, welcome to the show.
Hi, everyone. Thank you for having me. Thank you, Ken.
So excited to have you to talk a little bit about your new generative AI tools designed for workflow automation and network management stuff pretty specifically. Can you give me sort of the 10,000-mile overview of what you guys have been working on?
Yeah, sure. So we, Soracom, have been offering the Soracom IoT platform so that the customers can connect their devices to cloud environment and build an application on top. And our focus is to, remove all the blockers in building the IoT applications, especially when they integrate AI capabilities to applications. And, recently AI has evolved a lot, every day it's evolving. And its capability can add strong value to any kind of applications, and IoT is not an exception either. And in reality, IoT has required AI capability so that you can make decision based on data you collected, and then you can actually send the commands to devices in the real world and make things happen. And that's really what IoT is about. And we have been thinking about that since the beginning of our company. And recently, we announced the new service called Soracom Flux that you just mentioned. So what it allows you to do is you can actually connect various sensors and devices and cameras and any kind of devices that are connected to our platform. Or you can also connect some services in the web or any API that you want to integrate. And you can actually draw a line between them and build an application by using our low-code application builder framework. And as one of the actions that you can do based on the event coming in from the physical devices or API, you can also integrate the AI APIs like OpenAI, Gemini, Amazon Bedrock, and so on. And you can provide a prompt saying, for example, when the camera sends an image, you can actually say, hey, if there's some malicious person in the video feed, let us know. Send a message to Slack and trigger an alarm light in the backyard. So you can actually do that in natural language and build IoT applications. So that's what it's about. And we started to see customers taking advantage of it and building cool applications.
That's really, really cool. So we have the Soracom Flux announcement, which is what you've just been describing. Tell me a little bit about what Soracom Query is and how that ties in with Flux, or is that a whole different product, or what is Query?
Yeah, sure. Yeah, it's a new product that we announced as a public release. We have actually announced that concept a few years ago. So what it does is basically, we collect so many different kinds of data from our connectivity fleet. Whenever each STEM connects and disconnects from a network, we record that as an event. Whenever the devices send data, we record the data usage and so on. And also, customers can send data to our endpoint, and we have a time series database that we can keep track of all the user-provided data. So Soracom Query is a central component in our platform that collects all the data, both from the SIM connectivity fleet and also the user devices. And you can actually ask questions about the data you collected. You can just ask questions in natural language saying like, hey, show me my SIMs, where they are located and where they are connecting from. Or you can also say, hey, show me some problematic devices that are not reporting data in this period of time. And we actually generate queries, SQL queries behind the scene to our data warehouse and get the response back and generate the visualization of data and create a dynamic report based on the questions that the customers are asking. So these are for our customers to troubleshoot their devices or do some more complex analytical queries without having to have experts in the team. So again, we are trying to remove all the blockers in IoT development. So that's what we offered recently to lower the barrier.
Yeah, I mean, I know you're a big believer in sort of natural language user interface, and especially with AI tools, and the regular listeners of Embedded Insiders will know that I'm a bit of a curmudgeon about generative AI, mainly because I am skeptical about the sort of large language model general purpose type of generative AI. I'm much more interested in like very specific use case, not small data sets, but like tailored, designed for single purpose or specific purpose data sets. So can you tell me a little bit about the underlying algorithmic and data sets here within Flux and Query and how users can expect to interact with this generative AI?
Yeah, that's a great point, and I hear you. The still generative AI can give an answer that is not truly correct, or can come up with some hallucinated data. That's why actually when we integrate the Gen AI into our services, we make sure you have also control in terms of how the data is queried and transformed. So for example, in case of the Soracom query example that I talked about, what happens after interactions with AI is a SQL query generated based on AI. And you can actually look into what kind of SQL query that is generated after interacting with AI, and you can review it. And if there's a mistake, or if there's something that you want to tweak, you can also do that in the SQL editor part of the service. And you can save it for future reuse. And so basically, it's a if you don't want to think about SQL query itself, you can just interact with AI, and it's simply your data AI expert within our platform. But if you know the SQL query and want to have the control after generating some examples, you totally have a control for that. Likewise,
Awesome.
Yeah, go ahead.
No, I don't want to interrupt you. I was just saying that's great to know that sort of you guys are thinking about that, because obviously there's a lot of different use cases for IoT, as you all know, and tons of different use cases for potentially for AI and those interfaces. But some of them are going to be really sort of mission critical sensitive environments where you can't afford errors.
Right. Yeah, so likewise, you're right. For example, our customers have started to use our AI integration service, Soracom Flux, to monitor warehouse, and we see, if there's a malicious person or someone who is not wearing safety gear, they can get notified, and they can actually, trigger alarm light and things like that. So for that, there can be some mistakes generated from the AI. So we have recorded all the events and all the image coming in for the AI to make decision, so that in case there was some like a false alarm or some missing event, they can also look into what happened, and you can actually use that event and what happened as a way to learn or tune the prompt, so that the next time the AI can actually make a better decision. So both ways we are also trying to help and make sure we can also evolve the system and applications together with our customers.
Yeah, back in the old days, I may be revealing my age here, but we used to talk about what's the killer app for whatever technology was coming up. And it seems like right now, almost across any segment, the killer app for AI is computer vision. It's processing vision data, whether that's industrial inspection, security, warehouse monitoring, or more on the consumer side, security systems and retail and that kind of stuff. You guys are really heavily involved in that space. Can you talk about a little bit, if you don't mind me picking your brain on the forecasting side, where that's going? Is because it seems like AI is really good at this kind of image processing now, certainly in the near real-time space even. So where do you think that goes next? Or are we going to be looking at more leveraging generative AI toward other sensing and other edge AI processing stuff?
Yeah, definitely the analyzing image and video using AI, that's the hot topic, and that's something that we newly got as an ability in IoT systems. So any camera that can send that file to our endpoint can turn into AI-enabled camera by using our AI integration. So what's actually impressive is that you can actually give an instruction in natural language, meaning that anybody who has business knowledge and domain knowledge about some application, they can provide their knowledge, and the system can use that to make sophisticated decisions. For example, we have a customer using our camera device and sending those image feed to our endpoint and use the AI backend to count the. Well, they actually have a retail stores. Then they sell like a fresh vegetable and bento boxes and so on. They actually measure the number of bento boxes on the table, so that how many bento boxes are selling in each time of a day, and they can actually put more bento boxes if they are selling well. If they are not selling well, they actually reduce the number of bento boxes to produce. That way, you can actually reduce the food waste, and also optimize the revenue. And also, if they are seeing like too many bento boxes at the end of store opening hour, that would be food loss again. So they can actually send a notification to store staff to put some discount stickers on the bento boxes, so that they can sell more before the store closes. So this kind of thing is, of course, not a rocket science. By using AI image recognition, you can do that. But what is great about this example is store managers and store staffs, they don't necessarily have to have knowledge about programming or AI or IoT, but they know about the business logic and how they can actually generate more revenue and more value and reduce the waste. So their knowledge can be integrated into the actual real-world AI applications through this framework and the evolution of AI. So that's the really exciting part, and we are helping those anybody who has an idea to build applications. So definitely image recognition was missing piece for a long time, and also this missing piece was the ability for anybody to build the systems and give an instruction to the system, so that they can implement the business logic. So these two pieces are now fitting together. That's why it's really happening and giving lots of value to the real world.
Yeah, I think a big impact that certainly facilities managers and company systems designers and stuff are looking at now are, yes, we're implementing some more AI, sometimes really sophisticated AI systems at the edge. So they're starting to look at processing and energy power. So obviously you guys are designing some of these systems, so you're thinking about both of those issues a lot. Energy efficiency strategies, battery strategies, processing is always improving, but what are some of the balancing techniques that you advise your customers to think about when they're implementing a system, and that you see as sort of best practice?
Yeah, that's a great question. So at the end of the day, it's important to build a system that is affordable and energy efficient, so that it can run in a sustainable way. Today, when you use the cloud side AI, you're not seeing the actual consumption of power, but behind the scene, it's consuming a lot of power and energy. So of course, optimizing that by having local edge computing environment and applying some, just the right size model for each use case. That's actually important to save energy and making the system affordable and sustainable. So what I recommend these days is start with a large language model and whatever that you have, whatever the latest and greatest in the cloud, so that you can actually explore all the possibilities that you can do with your devices and your data. And once you understand what you can do with the current generation of AI and devices that you have, then maybe you can actually start to think about, hey, maybe this portion of the analytics can be done with a smaller model rather than using the full-fledged large language model. Well, this part of data doesn't have to be sent over to the cloud. Maybe that can stay in the edge location if you have enough computation resource and power in the edge location, and analyze it there, and just send the events extracted to the cloud side. So my recommendation is start with the full resource set, and then optimize after that. If you start from the kind of optimization of using the edge computing and smaller models, you can't fully explore the value of your systems and applications. So that's what I talk to of my customers.
That's a really interesting approach. I haven't had folks sort of explain it that way before, so I appreciate that. Kenta, we're getting near the end of our time here, so I always like to give you the floor. What didn't I think to ask you that you think folks should know about edge AI processing, some of the things that Soracom is doing that our listeners, engineers, developers, and whatnot should know?
Yeah, that's a great question too. So the by having the current generation of AI, and AI is evolving like every week almost. So the future is unpredictable in a way, in a good way. We can do a lot more by leveraging all these technologies available. So the what we want to achieve is truly to unblock all the barriers in making ideas and innovative things happen together with our developer friends and the engineer friends. And also now it's actually really business side logic and knowledge are connecting to the real world AI integration. So it's really exciting time. And one thing that I would like to say at the end is, we are here to make your idea happen. So any crazy idea is not crazy anymore. If you have anything in mind, please let us know. We will find a way to help you.
That's awesome. And this is the part of the segment where I do a little bit of plugging for our stuff. If you folks out there are listening and you want to deep dive into some AI at the edge topics, don't miss out on your opportunity to register for our free AI at the Edge Day, September 25th. It's a virtual event day. We're going to be doing a bunch of different sessions on AI at the Edge topics. You can find all the information about that at embeddedcomputing.com/webcasts or in the links down in the description. And I hope you do that. But in the meantime, Kenta, thank you so much for being my guest today. It's been really a pleasure having you.
Thank you so much, Ken, for having me. Thank you, everyone.
Thank you. And congrats to Soracom on a really cool announcement, really cool product. Looking forward to seeing some use cases happen. Folks out there listening, I've been Ken Briota, Editor-in-Chief of Embedded Computing Design and your host, and we will see you next time on Embedded Insiders.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.